Let's start looking at reactions and how we write up our reaction equations or our chemical equations. Okay, so what are reactions? Basically, I have reactants A and B. I mix them together and I get products C and D. Or maybe I have a single reactant and something happens and I get products. Or I have a few reactants and I get one single product. But basically, something happens, things react, and I get something new at the end. We describe these with our chemical equations. So there's a lot of different ways that we can tell a reaction is taking place. So basically, we have to observe. We have to have good observations as to what is occurring in our reaction. So I've got a couple of image sets here. In one of them, I have a white powder and a liquid is dropping into it. Well, we can see through the series of pictures that first we get some bubbles forming, some fizzing happening, and then we also have a permanent color change. So instead of just having a white powder, now there's something yellow there. In the second series of pictures, I have a beaker with something clear and colorless in it, and I have another beaker with something clear and colorless in it. When I pour one beaker into the other, some yellow stuff starts to come out of solution. It looks like a precipitate. It looks like a solid is crashing out of the solution. So what are some of our evidences then? Gas is produced, a precipitate is formed, we get a permanent color change, or there's an energy change. And we can depict an energy change. Sometimes we'll see something that is obvious that energy change is happening, or as we do our reaction, we can feel the reaction vessel either getting warmer or getting colder. Right? When we have our chemical equations, we use that to describe our reactions. So in your car engine, you get some gasoline, you get some oxygen, combustion happens. Products of combustion are carbon dioxide and water. Now, this right here is not a very convenient way of depicting a chemical equation. I would hate to have to draw all of this out all the time if I just want to depict the equation itself. So the way we usually depict chemical equations is symbolically. So octane, C8, H18, it's a liquid, plus oxygen gas, and then we're going to get carbon dioxide, and we get water. Now, when we think about how we are putting this together, we have to think about what is occurring during our reaction. Okay? Now, during the course of this particular reaction, it's probably very hot. It's undergoing in your car's engine. So think about this for a second. Should your water still be liquid, or do you think it's going to be high enough temperature that you end up with water vapor instead? So it should be water vapor. So we have all sorts of different symbols. Some of those common ones you'll see are L for liquid, G for gas, S for solid, or this AQ, which means aqueous, which means it has been dissolved in water. Okay? All right, so here again, we have some depictions of equations. Oh, I forgot to move this bottom one. So it's covered up by my little picture screen here. So formation of water from H2 and O2. So I get hydrogen gas, I have oxygen gas, and I'm going to get my water. Okay, at a high temperature, and then we condense it down. Now, one thing you notice is down on this bottom equation, you can't see the whole thing because I accidentally covered it up, but you'll see some coefficients in front of there. What we do is we balance our equations, and we will talk about balancing. But balanced equations are so that we satisfy the law of conservation of matter. So for this top equation to be fully done, I'm going to put that there, and now I have a balanced equation. Now, sometimes when we do reactions, we get everything in a perfect ratio where nothing's left over. Other times, something like this, here I've got hydrogen and nitrogen reacting to form ammonia. I've got my equation down here, okay? And so in the course of this reaction, my hydrogens are these guys. My nitrogens are these guys. And so I end up with, at the end, some extra nitrogen hanging around because this reaction had more nitrogen than necessary to run. All right, and then here is just a summary of a whole bunch of symbols. So our reaction arrow, basically I have reactants A and B produce products. My plus is this and this together. Sometimes what you'll see are things above the arrow. So in this case, there's a delta symbol above the arrow. That means that heat was added. There's another example there with iron. Okay, a catalyst was added. You can end up with all sorts of things that go above the arrow, just indicating that something else was present during the reaction, but it wasn't consumed in the reaction. The only one that we might deal with in this class is that delta symbol above the arrow. We won't be dealing with anything else above or below the arrow. Okay. If a reaction yields NR, that means no reaction. That means absolutely nothing happened. And then, as I mentioned earlier, we've got our little symbols in these parentheses. S is solid, L is liquid, G is gas, and AQ is an aqueous solution. And aqueous solution means dissolved in water. Okay, so aqueous solutions are dissolved in water. All right, and then there's just a final depiction of our water forming from its constituent elements with our balanced equation.